Bismillahirrahmanirrahim. So we were discussing H2 method of pavement design. Uh, in H2 method of pavement design, the unit of traffic is E-cells, equivalent standard axle load. And in H2 method, that axle equivalent single axle is taken as the magnitude is taken as 18,000 pounds, or in SI unit, it's 8.2 tons. So what H2 method assume that whatever, if imagine that if uh, one pass of 8.2 ton axle load will create one damage, what damage a load higher than 8.2 ton will create? Obviously more than one. And for loads less than 8.2, it will create a damage less than one per pass. The model is not very simple. It's not just like comparing a single axle load with the equivalent single axle load, but it's, the effect is grown exponentially. H2 method of pavement design, the classical method, it takes this power something between 3.8 to 4.2, but on average it is 4.0. While the practitioners in Pakistan, they just move it, they take 4.5 to create more conservative design. So conventionally, an axle is something that has got wheel on each side. And if uh, they are one at one better place, then it's a single axle. If there are two axles locating side by side, then it's tandem axle. There are three, that's called tridem axle. Then there are four called quad axle, and more than four axles, truck do exist, and that we call multiple axles. Now, so we consider two single axles. Then imagine A having axle load of 16.4. Then according to the formulation, the relation, one pass by A axle having 16.4 ton will be equal to 16 damages as compared to the single pass by 8.2 ton axle. That is 16.4 means you count them, they are 16 single axle. Though it's 16.4 single axle, but damage, numerically, it is equal to 16 axle, as you can count here in the animation. Now, if it is 4.12 ton axle, that you can imagine a lighter vehicle having a 4.1 single axle load, then 16 pass of 4.1 ton equal to one pass of 16.2, 8.2 ton axle. So as you can see this bar chart, in which, if you have 8 tons, that's damage is 1, and if you have 24 tons, the damage is 75 times more. One pass will create 75 times more damage than a single pass of 8 ton. One pass of 20-ton single axle load will create 36.3 times more damage than 8.2 tons. This is how you can read this graph. We'll actually take this thing in a separate chapter as a traffic impact and how to calculate. This is just an introduction. That's why we are stopping at that point of, the magnitude and the amount the road could be damaged by more allowing more vehicles that has more than 8.2 ton of single axle load. Now, this is a very good triangle that for pavement to fail, one of the three sides is enough of three parameters. The design thickness that may be not adequate will create the failure. You may have created thickness design, but the material design was not proper. You may not have catered it. For instance, you have used a 8500 bitumen and the temperature there was, around 50 degrees centigrade. So there the grade bitumen should be more harder, maybe 40, 50 grade. So you may have chosen, you will get the calculation anyhow. But this material, the wrong input of, wrong selection of asphalt grade may cause your failure. And you see, in highway construction, this construction quality control is more needed as compared to the other aspects of civil engineering design. For instance, uh, you may not have very good quality control of while doing the structural design or structure building construction, but the building may survive. It's because the ACI has got so many safety parameters that even you miss someone, the pronouns effect is not very much. We know that even the buildings in our region, they do fail. And we also know that most of the buildings, maybe 90% of the building, I believe, is not constructed by the qualified civil engineer, not supervised by quality, but still they are surviving. And that is because, because of the ACI code. It's so strong, it's so safer. That's why. But in ASHTO policy of design guide, ASHTO design, there are too much limitation. And there are too much, the design are based on the local conditions. So that's why you have a design, you adopt this ASHTO method because of being an American design, and you don't have an alternative design. And so is so that, sometimes, and again, the design is not a code. ASHTO design is a policy, the guidelines. Violation of guide load is not a penalized code. But violation of code is can be penalized. So if someone say has not taken your advice, and if he fails, then we can that is he has a right. He may think that your advice at that time was not feasible. So he cannot be penalized in the court. But the thing is, for when we adopt a building code, then there's a code and code has to be followed. Yes, if a material, if the thickness are not properly executed, for instance, we need an asphalt base course of say 70 mm, maybe 100 mm. And if the contractor has not provided that 100 mm, then this, then he may be penalized. But again, designer, if he has provided 100 mm, seldom it happens that he will be blamed for the design. It's the execution that's very important. And the quality control that, it's very important. So this is a troika of how pavement failure. What we call a premature failure pavement means it has not passed once we have designed for 20 years. And pavement has to survive this 20 years. But if it survives, say 15 years, well, you can to mathematically if it survives for 19.99 years, it's 20. But however, this is a premature failure. So we expect our pavement to pass its service life. So, but again, this will depend how you have designed, what material you have used, and what practices you have adopted, and what quality control you have exercised. So that's what C. Thickness design, material design, again, you will have a failure. If there's a fault in material design, again, you have a failure. And if there is a problem, this will be a disaster if the pavement. Because pavements are constructed from a public fund. It's not by personal fund, one thing. And people rely so much on the pavement in traveling that they cannot, a highway department cannot afford a premature failure because it will, slow down the economy of the country. So if, God forbid, if the road is blocked or it is being not usable, it is creating disaster to your economy. So you cannot tolerate this type of anything. Pavement failure is uh, is not desirous. It's not desirable. Now, what are the pavement? We have discussed it. We all know that in Pakistan there is rutting because of the high temperature. Even the load you can control, there's a temperature higher. If you go up to the upper Sindh, um, like Nawab Shah and maybe in Tharparkar or Jacobabad, you have higher temperatures. We all know that about what are uncontrolled heavy axle loads. Again, you have H2 method designed for the American conditions and you are adopting it in Pakistan condition. And that method actually is again too old to adopt it. But the question is whether you have the design, acceptable design. The answer is no. So why on the earth we have not created this design, we have not adopted the local design. People have practicing some variations. The problem is most of the time we get externally funded projects like World Bank, Asian Bank, and they do not accept your experimentation. They are, investing money, so they want us to to adopt a very reliable method. For according to them, is again most of the time is H2 method of payment itself. So even though I would like to adopt my condition, but road is not something to experience. Billions required for constructing 1 kilometer. And you cannot waste all this. This, yes, for research, you can adopt method, but again, this method to be put into practice is against a risk. And not many people, not many investors would like to take the risk. That's another reason that we may not have, people have been discouraged to use the local pavement design methods. And that's why not popular, not being practiced. People think that it do not exist. Now, look at why we say the method that has been adopted by we adopted H2, but there is a hell of a difference. Look at this truck. It's a simple two-axle truck having 6 tires, one axle here and one axle here. And it has got so for one US damage, this truck of us is creating 22 times because of the axle loading, excessive axle loading. What the transporter tries, the transport their willingness is to carry as much as load as could be. There are things what we call the plastic floor, I think. Plastic means something that is permanent. So since now how you see where is the rutting? If your asphalt is weak, then the, the depth of the failure will remain in asphalt layer, will not penetrate. So that indicates even though base and sub-bases are strong, subgrade is adequate, but it's the problem with the asphalt layer. One may be use of inadequate asphalt binder. The other may be the mix design. For instance, you needed say 4% asphalt, you have mixed it with 3.5. The other reason may be your asphalt grade is good, but the finer material you have used may have more than the required data, because this finer material also creates some problem mix design. Sometimes you have a coarser mix design, or sometimes you have other design of sometimes this in asphalt area because your finer material was not according as per specification. So anything that is being used for making asphalt layer, if your rutting is within the asphalt layer, then you have to remove that asphalt layer. There is nothing. No overlay of 2 inch will make this good. You have to remove this layer, throw it somewhere else, or sometimes you can use it in recycled material, but you have to relay this asphaltic layer. That's the only solution. The solution of rutting is to remove the layers. What layer is to, up to what depth it would depend on where actually your rutting is, up to what point. There is no alternative. There is no resurfacing. People think just having a say 2 inch layer will provide you the structure. That will again fail. So the wastage of the time, the wastage of money will be of no use. We must have, and I for a thumb rule, but remember it. It must have an actual extra asphalt base layer. It should be strengthened with an asphaltic base layer and then followed by asphalt fairing layer. And in a pavement, the costlier thing is an asphalt in a flexible pavement. So that's the problem. And the confinement is along the wheel. So that's we cannot shear failure as well, because this has this deflection, this deformation has caused the other part to rise above the neutral axis. Now we have this, but there again there's a problem in asphalt layer. There is an inadequate compaction. Normally, what happens during a construction is we bring an asphalt at 150 degrees centigrade, we mix it, and by the time it is because sometimes we have a cold weather, we have wind blowing, or traffic. My truck, this loading truck, is too far away. The plant is too far away, and when I transport it, the temperature becomes less. or maybe there is a problem with the mixer machine. Somebody has failed to check whether 150 this mix has been made mix at mix has been made at 150 degrees centigrade, or it may have been mixed at 120 degrees centigrade. And when consequently it reaches the site, it falls below 100 degrees centigrade. When it becomes 100 degrees centigrade, below 100 degrees, it has no flexibility to be compact. Normal compaction age is 100, 110. If it is lesser than that, even though you lay a asphalt concrete, it has been laid, but actually it is not properly compacted. For compaction, we do have the test. We take the core out and we do compare it with the density. But again, this failure is in asphaltic layer. This layer has to be removed. So whether the poor workmanship or poor selection of material or the poor construction technique may have caused this sweating. Anyhow, you need to get rid of this. Then you can see these deformations has undergone is in the weak subgrade. The previous slide we have seen that asphalt layer was affected. Again, obviously you will see, but there is no shearing effect. The neutral axis, the asphalt has not come out. So it means there is nothing wrong with an asphaltic layer, but there is something wrong with the subgrade layer. That's why it has deflected. Now the problem is you have to remove, even though asphalt layer was very good, your base layer is very good, but again, you have to throw all of them out. No, this is more disaster than the first one. The first one, an asphalt concrete, there was failure in asphalt concrete. Yes, you have removed it, but your base and sub base was okay, so you compacted in that. But here, you have to remove all the even the other layers. There's nothing wrong with them. So the estimating the subgrade strength is very much important. And then we have to know why this subgrade has happened. Maybe there is a water line that has been passing, and that passing of the water line may have created some moisture, and that moisture, because of some moisture, the subgrade has been compacted. Or sometimes we do this digging and we do this trenching while laying out this services line before construction road, and we have not properly compacted. Right. Anyhow, this is a disaster. And this disaster, again, you see, most of the time, if these things are catched during construction, maybe a poor design can be catered for. If it is the quality control is not good, even you have selected a poor material and someone has tested that material and he has an experience that yes, this is a CBR 30 material, CBR 30 material is not even so big. So he knows that by quality control, the material that is being laid, and if he knows the specification, and normally with his or her experience, it sees that these materials, although specified wrongly, maybe because of some typing error or something, cut and paste error, if you have a very good people with, a good head, good head on their shoulders, the quality control people, if they can even the ill comings in the selection of the uh, pavement material, sometimes the design. Experienced people know that for this type of road, asphalt bearing counts cannot be less than 2. Asphaltic base course cannot be less than 4 inch, because actually this is something, this is a very motorway road or maybe a very highly demanded road. It may not have this small thickness. Again, this comes by a very good, the person who is in charge, and when the drawing is put to him to be executed, by studying from the drawing, he can get it rectified. So for me, is the quality of construction or the quality of QC that is more important than the 3 parameters I've shown. Please. You can see the first picture. Please look here. Yeah, rutting. Why there is no rutting here? Why there is rutting, because you can see the behavior of the the layer beside those laden that has spotted out. But in this picture, you can see there is nothing wrong with an asphalt layer. There is a rutting, but this this is the secret. One thing. Secondly, what you do when there is rutting, you dig a pit 1 meter by 1 meter up to the full depth, and you just go into the trench and look for yourself. You will see what layer has been deflected or not. So that's how you do. There is always, you cannot, it, knowing rutting and the cause of rutting is also not very easier job. But normally if you have this section, and again with their experience as well, experience is very necessary in knowing these things. So you can always dig a pit, dig a trench or pit 1 meter by 1 meter normal, and then you can stand inside it and you can see which pavement have failed, which layer has not failed. You will see yourself. So this is how rigid pavement is constructed. Now it's not like this. We have other method, but it's used well. But it's again, it's just paver-like thing in asphalt, cement concrete road construction. So that's actually ends our discussion on